Okay, so this is just a quick video to show you what we should have done in one of the sessions for the production of a high strength ceramic, zirconia in this case. So this is where you would have prepped the tooth in the clinical skills lab, brought it down to the T lab, and we would make you a high strength crown. So what we'd do to start with is design the crown on a CAD package. So this is what you can see on the screen now. This is sort of the housekeeping part of the software. So we put the details in, so telling the software that we've got a model that has a crown prep in the place here, and that we've got two adjacent teeth. And then we pick the material that we're going to make the restoration from, and some preset parameters come up. We can change those if we want. We'll talk a bit through those in a little while. And then once we're happy, we can click save, and then this lights up all of the buttons down the side, including the scan features. So now we can click our scanner, which is just here, and you can see we've got one of the IRS clinical skills model on, and there's the prepared tooth. And we've got a couple of scanners, so we just click the scanner that we're using, and there we can see that we've got the arch form and the details that we've just put in carried through, and we can start the scanning process. You can see the scanner just jumped into life there. So we tell it that we're scanning a stone model. We can also scan impressions and bite registrations and so on. You'll notice that the model's covered in some white powder, and that's so that the optical scanner can see the model clearly, because the plastic material is slightly translucent. We're going to do two scans. We're going to scan the model base, so we're going to do an overview scan of the whole model to start with, and then we'll do a separate scan just of the individual die. So it does a very rough scan to start with, just to allow you to crop the image down and reduce the amount of data that you're going to collect. I just press next on this particular one and just click the whole lot. It doesn't take too long to scan this model. So you can see it buzzing away now, and it turns the model round and scans from each different direction and gradually builds up an image. So some of the areas that you can see on the scan that's appearing on the screen, you'll see that there's some missing data around the teeth, in the gingival pockets, in between the teeth and so on, and that's one of the problems with scanning, trying to see in between standing items, looking into holes in effect, is always going to be a problem using this type of scanning, or is always going to be challenging anyway. But we have some little tricks that we can use to overcome that problem. So there's our model scan. We're particularly interested in this prep and the adjacent teeth, the contact points obviously, and you can see there's a bit of data missing just there, so we can focus just on that area and click add scan and see if we can get some better detail of that area, and likewise on the contact point with the central incisor as well. One more time, and if it still doesn't work, the nice thing about working with models and sectional models that we usually have to scan, of course, is that we can remove items and allow access for the scanner to see the data that it's struggling with, or the area of the tooth that it's struggling to capture data for. So there I've just removed the prep, and of course we can do that on our sectional models as well when we've made one of those in the lab, and then we can click add scan and it should be able to pick up that detail a little more. You can see it's just got a bit more there, and it's got sufficient for what we require. It's also added a little bit on the distal of the, on the mesial of the central as well. Okay, so once we're happy with that scan, and we've got enough data, we can go on, of course, and create perfect model if you like, but it's unnecessary for just making a crown, so we tend to just leave it at that. Once we're happy, we can go on to the next stage and we can crop any data that we don't need away to tidy up the image a little bit and make the processing time a bit quicker when we start putting the models that we've scanned together and start designing the actual crown. So it's just smudging all its scans together that it's done, and then we should be able to crop. This is the point really where if I'd cropped at the beginning it would have speeded things up. Anyway, it doesn't take too long. You can see the inside of the scan. The nice thing about scan data, of course, is it's infinitely thin, so you can scan an impression, flip it over, and you've got the model. So that allows us to just scan an impression if we've got a good enough impression in the right material and so on. So I can just highlight the area of the model that I need, crop the rest away, and now we can go on and make a detailed scan of the prepared tooth. So we'll go on to the next stage in the wizard, and you can see it saying do a preparation scan, and it's asking which holder I want to use to put the prepared tooth in, and we've got this, it's called a multi-die holder, so we can pop that in place. And then it's a little bit messy when we're working with these plastic teeth because we have to spray everything to make sure that it's nice and opaque for the scanner. Like so. And then once we're happy, we can pop that in place and finish the scan, or scan the prepared tooth. And then what we'll do once we've got this scan into the software is align the two scans together. Again, it's just done an overview scan to start with. We can crop round so it's only scanning the area that we're interested in. You can see I've just cropped it out quite crudely. I'll crop it again at the end of the scan. And you can see now that the scanner is going to have nice clear access to each side of the die. So that's going to allow us to get a really good scan. Okay, so that's the scan of the preparation finished, and again we can check that, add if we need to, and then crop it down to the size that we need, just to reduce the amount of data again. Just off the screen, sorry about that. I'm doing all this one-handed. Right, there we go, there's our trimmed up scan data. And now we can go on to the next stage, and the wizard asks us if we're just done, if we're just doing a design, or whether we want to go on and design the actual restoration. So it'll link back to the CAD software, and it's got the two scans there on the screen. So the next job is to align these two, make sure that the software knows which way around the die goes. So it tells you in the wizard down at the bottom, it's foolproof, this software, anybody can do it, what to do. So you just click on the die and you click on the same point on the model, and you can see there it's aligned the two, so you should see a nice sort of speckled surface where the two scan bits of scan data are coincident. Then once we've done that, we've gone to the next stage, and we can identify the preparation margin. So again, this wizard down in the corner is telling you what to do. So we're on detect, so it says click on the margin and click on the buckle side first. And as we roll our cursor down over the prep, we can see a cross section in that little purple window and find the margin, and then it auto detects all the way around if we've got a nice crisp edge on the prep. If it's gone awry somewhere, you can adjust and edit, of course. So there's some tools here just for adjusting, and you can grab hold of the margin and grab hold of the line and identify the margin that you want to work to. And then on to the next stage, and there's different ways of going about. Oh, sorry, I'll just do this bit. Yeah, this is the path of insertion. So it's in case of any undercuts. So particularly significant when we're working with bridges where we've got two preps, of course, but even on a single prep, if there's any undercut, the software wants to know what to do with it, either block it out or overmill the crown or whatever it is that we're going to do to accommodate it. So we pick the path of insertion for the restoration, and then we go on to the design of the crown itself. So at the next stage, sorry, I keep forgetting bits. This is putting the cement lute on, so you can see the cement lute there highlighted in, or the spacing for the cement lute, I should say. Then we can increase that, and we can select how far from the margin, so you can see now that little green band around the margin has increased in width. So the gold is showing where we're putting space for the cement loop, and we can increase or decrease the thickness of that gap, and then we can say where we want it to start. Now we're on to the design. There's different ways of designing the crowns. We've got a library of teeth. This way that we're using here is to mirror the adjacent tooth. So we select the adjacent tooth and it mirrors that tooth, and then we can just drag it round and put it into place as best we can. So then we can move, rotate and scale this shell of a crown, if you like, in any direction we wish. So, and there are different tools to allow you to do this. So to limit the movement in just one direction, for example, likewise if we're scaling it, making it bigger, we can scale just in one direction. So that's the little buttons that you can see underneath. And then we've got rotate and move there as well. So I'm just trying to align this as best I can with the incisal edge and the labial surface, making it look just about right. You can see that the prep at the back there is just poking through a little bit. So we're going to have to just scale this up a tad just to make sure we're accommodating the prep. I'm not sure whether these plastic teeth were in the model base perfectly, or whether it was just a poor prep. Anyway, the software will compensate because some of those parameters that you saw right at the beginning give us minimal thicknesses for the material and so on, so it'll overbuild in that area to make sure that we've got the minimum required thickness of this particular material. And we selected zirconia, so it'll use about 0.4, 0.5 millimetre. So once we've got it about lined up, we click next, and it smudges that shell into the margins all the way around, and we can then move around and check and adjust as we see fit. So you can see the overbuild at the back there on the platel aspect. And at this stage we can drag out parts of the tooth, the entire tooth, half of the tooth, so we can grab cusps and pull like so. We can, if we're working on molars, just pull a ridge or a cusp, and again we can move the entire tooth. And we have some other tools here as well which allow us to adjust the occlusion if we've scanned the opposing model in, and trim back to the contact. And we've got a virtual wax knife so that we can add and remove material from where we wish on the crown. And there are quite a few other little bits and bobs tools in there that we can use as well, and we can refresh and go back to stage one if we like and use a different design method and just pull a tooth out of a library of teeth that we have stored in the software and put that in. And once we're happy, we click next to recenter that, and the crown then is lifted off the model, and you can have a look in. Make sure everything's as you expected. The blue dot that you can see is where we've got a contact point with the adjacent tooth. And once we're happy, we can click done and send it through to whichever production process. Here I'm just going to click save to file and save it where we can find it so that we can load it up into our milling unit. Okay, so that's what you would have done. This is the milling unit that we used, linked to a PC obviously. So we load the file up into a piece of software in this PC, and that creates a CNC file for the milling unit. So it tells the tools where they need to go. Those are the tools. We've got 3 burrs in there of different diameter. This is the blank that we cut out of. So this is zirconia in its green state. You can see it's almost like chalk really. So the blank goes into the chuck, the milling unit sets off, we've got a dust extraction and mills the crown. We've got different materials that we can mill from, and different burrs that we use for the different materials and so on. So we've got wax and plastic there, we've got for making patterns, and then we've got other materials like the Vita material and the Lava Ultimate. You see some others that were done last year that failed actually. So they're the crowns. You can see that they look very big, and that's because we mill 20% bigger than the desired object that we want. Because when we sinter this zirconia material down to its final state, it shrinks by about 20%, so we have to compensate for that. So here's a pre-mold that's been milled. You can still see the little tabs on the side where it was connected to the puck of material. So we trim those off, and then we colour the material using some of the particular stain that goes with zirconia. So we drop it in there for however long we need to, and we end up with the dye soaking into the porous material, and then we sinter it, and you can see that it reduces down in size to the correct size. This is the sintering furnace. We pop it on these beads, pop the green state zirconia into one of the little crucibles on some beads, and program the furnace up to go through a particular cycle. And of course we follow the manufacturer's instructions, which are over here on the wall. So there's the temperature somewhere, that's the properties of the material, and down at the bottom you can see that we take it up to 1480 for 2 hours, but we can only go up at 8 to 15 degrees, somewhere between 8 and 15 degrees per minute. So the whole cycle with cooling as well takes somewhere around 12 hours. Okay, I hope that helps.